Hi, welcome to my channel again after a long time. And for this video, I have got something exciting for you guys, but it will not as be exciting as you might think it is. So for this video, I'll be explaining about the safety of my new HV generator that I have made with a flyback transformer. So let's get started. And this was it was a successful project, I guess, but it was not successful as you might think. So let's get started. So when I first got the flyback, I directly connected to my ZVS. I mounted these 6 primary coils right here, and I powered it with 12 and I powered it with 11 volts, and it made us some violet long arcs, at least 5 to 6 centimeters. I was pretty impressed when I first got the flyback, and this finally worked, because throughout my electronic hobby I have never, this was my first time making a circuit that have worked, because most of the time my circuit just end up blowing up or doing something like that. But I don't, so I just skip circuits and make things with motors. But I have now made this circuit. This circuit was super powerful, and it was making super long thin arcs with very less stress on the ZVS circuit. That meant that it was perfectly tuned, and it doesn't need any more extra tuning. So let's start with the bad news of this circuit. So when I first got it to work, and I was like pretty excited and stuff, and then now the problem is, then the second day, Dad told me that this adjusting these two black knobs right here will adjust the output volt, and I was like, wow, let's increase the arcs to 8 centimeters. And that was the biggest mistake of my life, because I didn't know that so I just tried it. I didn't know what are the consequences of using these two knobs, and I didn't know what will happen when I use these two knobs. I just thought when I turn this knob, the arcs will get bigger and brighter. I tried that with my flyback. So I powered it level point level volts, and I used the insulated screwdriver so I don't get shocked. I spaced them like this I spaced them like this, and then I have powered them, and it made this long blue purple arcs again, and I was pretty happy. So I turned this two knobs right here with a screwdriver, but I didn't know turning this knob fully will damage the flyback badly. And I was like, I turned full right, and this is full right, and the arcs were getting whiter and brighter, and I was like, wow, my circuit is making some good arcs right now. But I didn't know white arcs meant that the flyback's insulation is damaged, and the arcs will be unpredictable, and it might shock me to death, man. It might have not, not like death. Like my hands might have got paralyzed by these things. So when and after testing and making the white arcs, I turned off the power. And I used to Google to search if making white arcs are good for the flybacks or bad for the flybacks. And then when I realized that making white arcs means that the flyback was completely damaged. Flyback was completely damaged and things, and the insulation was completely broken inside, and that meant the insulation was broken. This carbon thing right here is this carbon thing right here will be also leaking corona discharge, and that meant that the efficiency will be low, the voltage will be low, the aux will be shorter, and I just lost this brand new flyback that I bought for 150 rupees. But I have learned my lesson, like turning this knob means risking the flyback's life. And when you are guys gonna actually try making these ZVS circuits and all of these things, just make sure that if you're going to use these knobs, make sure that you know what they actually do to the flyback, because I didn't know what they were and I didn't know what are the bad things that will happen when I turn these knobs. So make sure that you guys also don't do that. So let's just continue what happened with me. And I also got shocked by this because as you can see that this is a metal switch that I took off from a optic board, I guess. I don't know what its exact name. And I was like, and after the white arcs were made, I knew the white and after the white arcs were made, I searched it in Google and I realized it was dangerous and the flyback's going to leak and the arcs will be unpredictable, and there's a risk that I might get shocked. So next day, I powered it again with less voltage at 7.4 volts, and the arcs were alive again. They were purple but they were much shorter and they were less brighter. And I was like, okay, fine. It didn't make any of those some damaged noise. So I was like, okay, let's add another 3.7 volt battery, and it made a level volts in the input, and that's when the flybacks actually backfired at me. So when I powered it, the flyback made this. The flyback made a. When I powered it, and I didn't even touch these wires together. The wires were just isolated from each other, but it still made a crackling noise, and I was searching where the noise was coming from, and I noticed that this insulated pin and this pin were shorting like crazy. Then that meant that this flyback floater has been shorted internally and externally. This might have totally ruined my ZVS circuit, but I have managed to figure out that this flyback is no more safe for me nor my ZVS. And I was up to, I was about to show this to my school exhibition, but this flyback transfer showed its second phase before showing this to my school exhibition. Just imagine what would have happened when I showed this to my school exhibition. You wanna know? Okay, let's get started. So let's say I'll explain that. So that it makes some crackling noise in here, I brought these two wires together, and they made an arcs. When they made these arcs in here, the arcs stopped in here. So I was like, okay, it's now no problem. But when I touched one of the input wire, it shocked me. It was not like a severe shock from some direct output wires. It was just a small. It was felt like a small mosquito bat shock, I guess. But that's fine though. And that shock made me realize that the flyback is completely unusable. This flyback should be replaced and stuff. So I got shocked by these metal switches, and I just touched one side of the input wires. I didn't touch both of them. I just touched one positive of the input wire, and this black wire right here was touching my wooden table, and this wooden table was connected to a metal frame. The bottom, it was like some metal frames like this, and this negative wire went through the wooden table and through the metal rods and through the forearm, through my feet, through the input. So some people will assume like, means if you have insulation, high voltage is safe, but no man, it passed through the wood, it passed through the wood, it passed through the floor, and it came to the input voltage to shock me. From this point, you will know that how dangerous a high voltage generator is. You will know because you cannot exactly know if it's dangerous or not. Even if you have proper insulation, even the tiniest gap is enough to shock the shit out of you. So, hope you have learned your lesson when you're trying to make this exercise, some of these flyback ZVS HV generators. Just make sure that you don't do the silly mistakes that I have done. I have learned the lesson. Okay, so just to remind you, if you don't know what these knobs does to a flyback, just don't use them. If you're experienced, if you know how to exactly operate them, if you know the minute operate, if you can minutely operate this, you can try, but the flyback will be at great risk of going kaboom. Flyback would be at great risk of going kaboom, but it might give longer rush if you tune it to the perfect alignment. But if you don't want to risk your flyback and waste your 150 rupees, just make sure that if you don't know what this knob does, just take some Fevikwik, you can apply it on both of these two knobs, and after that, so you cannot even accidentally turn the knob because it's glued to the body. Hope you guys. So let's just look at the ZVS circuit a little, so you guys can know what it actually is. And the circuit is a little messy, but it worked, man. That worked. And some of the YouTubers and most of the people use Torride cores, but you can also use a Farad core if you're making a flyback transformer. A Torride works better, than this, but it is at a slight different. It will just make a slight difference. And I have used this to 0.47 UF capacitors, and I have used the IRFP540 MOSFETs and N-channel MOSFETs, and used a 10K, a Xenon diode, and some wires and some thick enameled copper and some not so thick but not so thin enameled copper wire on the primary, and that's it. It's pretty much it. And I forgot that I used the 330 ohm 2 watt resistor on both sides, and I've also used a fast diode, and I also used a fast diode on for the gates and source of the MOSFETs. So then that's it. It's just pretty much that's it. And for the power supply, this lead goes to the positive, and this lead and this wire goes to the negative. And there's not much thing to tell about anymore. And just make sure that if you are, and in my next video I'll just swap off the flyback with a new one. Hopefully my dad buys it for me. Okay guys, so thank you for watching my video. Make sure to smash the like, subscribe button, and see you guys later. And before that, I'll be posting a better version of this flyback transformer in my upcoming video, so stay tuned, and I will use a newer transformer. So bye.